So let's go ahead and do these practice problems. And something to keep in mind is that if we are at standard temperature and pressure, and just a quick reminder, standard temperature is 0 degrees Celsius or 273 Kelvin, and standard pressure is 1 atmosphere of pressure. And so if we are at standard temperature and pressure, these are the temperatures and pressures that we're at, and we can convert volume to moles. So if we're at standard temperature and pressure, we can take liters and convert to moles. And we can take moles and convert to liters using the fact that 1 mole is equal to 22.4 liters. Now, just to give you perspective, that's about a little less than 6 gallons. So 1 mole of gas will consume about 6 gallons of volume. All right, so let's go ahead and do some practice problems. And I'm going to go ahead and write this at the top here, that 1 mole is equal to 22.4 liters. And these problems are really, really easy. So a chemical reaction produces this many moles of oxygen gas. And so if you can imagine you have a chemical reaction, and you can actually do some stoichiometry to calculate how many moles of a gas are being produced. So let's just say that's what's happening, and we're gonna get there in the next class period. But anyways, let's say that we're producing 0.068 moles of oxygen gas, and the question is, what is the volume in liters? So we're given moles, and we can go from moles to liters. There's this many moles of O2, and then moles of O2 on the bottom, and we're gonna go from moles to liters. And we know that 1 mole is 22.4 liters. And all you do is you type that in your calculator and you get your answer. And what you end up getting is 1.52 liters of O2. And this is your answer there. It's that simple. All right, this next one. This next one is saying a sample of hydrogen gas occupies 14.1 liters at STP. How many moles? Okay, so this one we're now going from liters to moles. And so I hope you see that these problems are really, really simple. So if we have liters, we can go from liters to moles. We know 1 mole is 22.4 liters. And all you gotta do is type that in your calculator, and you end up getting 0.629 moles of H2, of hydrogen gas. And remember, hydrogen gas is a hot wrinkle. All right, so let's go ahead and take a look at this next one. This next one has an extra step involved, and so let's go ahead and take a look at it. But just remember that 1 mole is 22.4 liters. And that is on your equation sheet. You don't need to memorize that number, although you probably will because you'll be using it quite a bit. All right, so a chemical reaction produces 98 milliliters of sulfur dioxide gas at standard temperature and pressure. This one's asking, what is the mass in grams? So it's giving us milliliters, it's asking for grams. And so let's go ahead and write a flow chart here. So if we have milliliters, we can't just go from milliliters to moles because the conversion is liters to moles. So we need to take the milliliters and convert them to liters first. Now, once we have the liters, we're trying to eventually get to grams. So we're trying to go to grams. But again, this conversion here is between liters and moles. So once we have liters, this is liters, we go to moles. And then once we have moles, we can just convert to grams like we always have been doing. So once we have moles, we can go to grams. And so this is our flow chart. So we need to take the milliliters and convert them to liters first, and then we go from liters to moles, and we go moles to grams. And so we're given 98.0 milliliters, and milliliters go on the bottom, liters go on top, milliliters cancel, and then now that we're at liters, we can now go liters to moles, and then now that we're at moles, we can go moles to grams. And so that's our setup there. Now, when we go in between milliliters and liters, we know that 1 liter is 1,000 milliliters because we have the metric system memorized, or you can just Google it. Not on the exam, though. Then we can go liters to moles using this here. So we know that 1 mole is 22.4 liters. And then here, we're going between moles and grams, and we know 1 mole is going to be the molar mass from the periodic table. And so we've got to look up the molar mass for sulfur. Let's go ahead and use some rounded numbers. Sulfur is 32, plus oxygen is 16, but there's 2 oxygens, so it's 16 times 2. And when you add this all together, you end up with a molar mass of 64. And so all you need to do now is type this into a calculator. What you end up with is 0.28 grams of SO2. So 100 milliliters will give you 0.28 grams of SO2. And it's pretty amazing to think about because it's 0.3 grams about are in 100 milliliters volume of gas. And just really shows you how gases are mostly empty space. There's a lot of empty space between them, and so it really the density of gases are very low. All right, so let's go ahead and talk about this next one now. This next one is giving us grams, okay, and it is asking for liters. And so this is going to actually be really important that you do this part, all right? Pause the video for just 20 seconds. Just take 20 seconds of your time to do this. Pause the video, and I want you to come up with this part right here, but for this problem, all right? So go ahead and think about, we're given grams. How do we go from grams of a gas at standard temperature and pressure to liters? So go ahead and do that. All right, so we're given grams. And we know we can go from grams to moles. Been doing that since the unit 2. So you can go from grams to moles. And we know that once we have moles, we can go from moles to liters. And it's that's our setup there. So we have 77.0 grams, but again, we've got to go from grams to moles first. And then we are going to go from moles to liters. And it's nitrogen dioxide, so that's nitrogen dioxide is NO2, so we can figure out the molar mass of that. We know that 1 mole of nitrogen dioxide is going to be, well, this is 14 plus oxygen is 16 times 2. And so that is 46. And then we know that 1 mole is 22.4 liters. And then all you gotta do is type that in your calculator, and you end up getting 37.5 liters, which is actually exactly 10 gallons. Yep, it's 10 gallons. And that's liters of NO2. Put NO2 there. All right, and it's really these problems are really straightforward. It's just recognizing that you can go from moles to liters at standard temperature and pressure using 1 mole is 22.4 liters. And then if you're not given moles, you just need to convert it to moles. If you're not given liters, you just need to convert it to liters, and you just go from there. What I will say is that, so what I'll say is that we are going to eventually take this and apply it to stoichiometry, so it is going to be important, but these problems are not too bad. So if you have any questions, come to class with those, and you have a great day.